Hello friends, good evening. So today we will see furthermore questions for a data science interview. Okay, so let's start with today's first question. So first question is like, what is ensemble learning? What is ensemble learning? Try to answer this question in your way. What is ensemble learning? Take few seconds and give me response in chat. Okay, so assemble learning methods are techniques that create multiple models and then combine them to provide improvised result. Okay, means sometimes we get when we run our model, right? Our model is good, but it is giving us overfitting scenario or underfitting scenario. Okay, we want to solve that issue, right? So in a which way we are going to solve that issue? Then the assemble learning came in a picture. In assemble learning, we can run our model multiple times. Multiple models we are running, and then the result of that model we will combine at the end. Then we can overcome the issue of overfitting or underfitting and getting better accuracy of our model, right? When we run any single model, okay, the accuracy may not be that much great, but if we run that model multiple times, the average of that model will be our output, and it should be more accurate as compared to a single model. This is the assemble learning technique. Now, next question is, then what are the types of assemble learning? What are the types of assemble learning? Okay. What are the types of assemble learning? Okay, so there are two types of ensemble learning. One is bagging and one is the boosting. Okay, so what is the difference between bagging and boosting? How it is working, right? If we know ensemble learning is a technique that is building multiple models at a time, right? To avoid overfitting. There it have two techniques, but in two techniques what is the difference? How can we differentiate? This is the bagging technique and this is the boosting technique, right? So in a bagging, the example of bagging, we can take it as a random forest. Okay, random forest is the assemble learning model. Okay, in that what we have done, if we have 100 number of records in our data, we can take sample of 20, 20, 20, 20, right? And then we run our model on that 20 sample. Okay, our decision tree model on that 20 sample, and then take it the output of that model. For example, we have problem of classification technique. Okay, in that we have firstly run our model on 20% of data and give the output. Okay, output is 0. Then again we take 20 samples and run the decision tree model and check and give the output. Okay, that is 1. Then again we will do same, run the model and taking the output. Okay, now we have run multiple time the decision tree. Okay, then we have get the multiple output. Okay, so what we are going to do next, we take average of that output. If we have continuous output, continuous data as our output, we will take average of the output. That will be our final output. Okay, this is the bagging technique. Okay, and if we have classification problem, then we will take most repetitive value as our output. Means example, if we are running 5 times a model and we are getting 0 1 0 1, we are getting 3 times 1 and 2 times 0, then we are going to select 1 as our final output, right? This is the bagging technique. Then what is the boosting technique? Okay, so if we are having, if say consider same data sets of 100 variables, 100 data points. Okay, in that we can take some sample data, 20 variables, 20 of the records, and send it to the first model. Okay, and take prediction of that model. Okay, after that model we are finding like some of the records are not accurately classified. Okay, so what we will done, we will send those record with another record to the next model. Okay, model number 2. Then that model might could be some record are not correctly identified. It will just tell you 2 or 3 records wrong. So we will take that 2 or 3 records along with other record and send with the next model, right? And at the end, we will combine the models and solve the issue of the accuracy, and we will get the Becker accuracy. Means the difference between bagging and boosting is like bagging, in the bagging models is running parallelly. Okay, but in a boosting models are running sequentially. Okay, means one model runs and the output of that model we will send input for the another model, right? So these are two assemble learning techniques, and this is the difference between them. And these assemble learning techniques are used to overcome the issue of overfitting and underfitting. That means to improve accuracy of our model, right? These are two techniques we are having. Okay, now today's next question, what is selection bias? Question is, what is selection bias? Think about it. What is selection bias? Think about it and try to give answer for this. What is the selection bias? Okay, So selection bias is the bias introduced by the selection of individuals or a groups or a data for analysis. Okay, when we are taking sample, okay, when we are taking sample for the analysis, that time selection bias will be occur. Okay, when we are not follow proper randomization. See, when what we want our data randomly distributed. So when we are going to select some sample from our data, that time we have to maintain a randomization. Okay, if that time any bias will occur, that is the selection bias. Okay, it is sometimes referred to as selection effect. Okay, yeah. So do you understand what is the selection bias? If and one more thing, if we are not taking selection bias in account, means we can not take it into consider, some conclusion of study says that it will not give you the accurate result, the model will not give you the accurate result, so we have to solve that. Okay, so whenever you are going to take the sample, you have to follow randomization, right? We want our data randomly distributed, but if we take samples from our data, if there is no randomization there, so selection bias will be occurred. But before applying a model, if we are getting accuracy less, that means it could be a selection bias, right? We have to solve that. If we are not going to solve that, it might be decrease our accuracy or might not give us the proper prediction. Okay. Okay, now the next question is, what is Tf Idf factorization? At least tell me full form of that in chat if you know. What is Tf Idf factorization? What do you understand from that? Tf Idf. Okay. So Tf Idf, it's just the short form of turn frequency inverse document frequency. What is the full form of that? Turn frequency inverse document frequency. It is a numerical statistic that is intended to reflect how important a word in a document in a collection of corpus. Did you understood? Means when we have extracted some reviews, for example, okay, we have some collection of words, right? In that, how could we find out which of the word are repeated more time, which of the words are more important, right? So what TF-IDF will done, it will give weightage to the frequency of word, okay, and then it will show you that word in a bigger format, right? That is the TF-IDF factorization. It is assigning weightage to the word that is more frequently occur in a collection of data, right? The TF-IDF values increase proportionally to the number of times words appear in the documents, right? That is the vectorization. See, means when we are calculating TF-IDF for any of the data, we will plot words, okay? Their vector for that words, and we will giving weightage. Okay, this word is present this many times. Okay, that much weightage to that word we are giving. And after that, if we plot word cloud or something else to visualize which is the more important word, it will reflect, right? Because the weightage of that word is more, right? Because TF-IDF is calculating weightage for a repetitive word, right? Okay, so uh, we will go for today's next question. That is like, what is the difference between regression and classification ML techniques? I will write it down if you haven't understand. What is the difference between regression and classification ML technique? Okay, try to give answer for this question. What is difference between regression and classification? Okay, so the difference is like both regression and classification. Firstly, we will understand both regression and classification techniques are supervised machine learning algorithm. Okay, in supervised machine learning algorithms, we have to train our model using output columns, using output data, and, and then predict our future outcomes. Okay, if that future outcomes could be binary, for example, yes, no, male, female, ham, spam. Okay, so that is the classification technique. But if that outcomes is continuous values, for example, 0 0.5, 0 0.1, 1.2, right? 1, 2, like that. So these are the regression techniques. Okay, so this both regression and classification techniques are belong to supervised machine learning technique. Okay, what is the supervised machine learning technique? Here we have our input variables and output variables, right? With the help of that, we can predict our future labels, our future outcomes, right? If that outcomes in a binary format, then it will be a classification technique, right? If we have outcome like yes, no, male, female, ham, spam, A, B, C, D, right? Something like that, then it will be a classification ML technique, right? But if we are having our output continuous, that means continuous number, so that will be a regression technique. Okay, is this difference clear? Okay, so we will move for today's next question. The next question is, what is collaborative filtering? Is collaborative filtering? Okay, you have 10 seconds of time to respond, to think about it. What is collaborative filtering? Okay, so collaborating filtering used by most of the recommendation systems to find out patterns or information by collaborating viewpoints. Okay, example of that is like, if we consider one of the user, if we want to predict rating for that particular user, it will be based on his last rating what he have given to the other movies, right? With by collaborating those reviews, those ratings, we can predict that okay, this movie is he is going to like or not, right? So for example, if one of the person, he is watching Harry Potter series, right? And he have given 4, 4.5, 5, 4, like that kind of rating for first three parts. Okay, first 3 to 4 parts. Then we can predict, okay, then we can predict, okay, he is going to like next part of Harry Potter or not. On that basis, we are going to give recommendation to those user, right? This is your kind of movie and you are going to like, right? So this type of filtering is, or recommendation is using nowadays like IMDb, Netflix, Book My Show, right? And some of the e-pay website like Amazon, Flipkart, that are also using this. Okay, so collaborative filtering is nothing but it is used to find out pattern or information by collaborating viewpoints. Okay, if you go on Amazon, if you take example of that as well, okay, so if you go on Amazon and you search for a Samsung phone, okay, then after some days you can see there is recommendation for Samsung headphones as well to you, right? Why? Because whatever ratings you have given to the phone or whatever you have searched in that might be, or you are interested, right? And you want might to purchase next product in that series, So on the basis of your previous rating, past rating, it will recommend you the things that are related to those, right? That is the collaborative filtering. Now, today's next question is, what would be the type 1 error? What the type 1 error? Okay, take some time and think about it. What would be the type 1 error? Okay, this one we can understood with the help of one example. Okay, for example, we can consider a scenario. Uh, okay, we want to find out if there while studying, if we listen to music, does it improve our memory or not? Okay, this problem. Yeah, is example clear for you, right? Means when we are studying, if we listen the music, is it is improving our memory or not? Okay, so here, what is our null hypothesis? Listening to music while studying music does not improve memory, right? While studying, if we listen to music, it does not improve our memory. That is the null hypothesis. What is the alternate hypothesis? Listening to music while study improves our memory. Okay. Now, what does mean the type 1 error? It means that we reject null hypothesis when it's actually true, right? Our null hypothesis is true. Like when if we listen the music while studying, there is no improvement in our memory, right? So the type 1 error is like we will reject our null hypothesis when it is actually true and accept a alternate hypothesis. Here is the null hypothesis that music does not improve memory, right? But type 1 error would be rejected and say music improves memory when it actually doesn't, right? So did you understood now what is the type 1 error? Means it is rejecting the true condition, what we are having, right? And accepting the alternate hypothesis. That is the type 1 error. Okay. So today's next question is like, what happened to the confidence interval when we introduce some outliers to the data? If we have outliers, what happened with the confidence interval? Try to give this answer for this question. What happens to the confidence interval when we introduce some outliers to the data. Sorry. Firstly, try to do what happened with confidence interval, and then if you are knowing that, what is the reason? Okay, so confidence interval will increase with the introduction of outliers, right? If we have outlier, our confidence interval will influenced by those outliers. But why? We know that the confidence interval is depend on the standard deviation of the data, right? If we introduce outlier into the data, standard deviation increase, and hence the confidence interval also increases, right? So if anyone asks you what happened with the confidence interval if you have outlier, yeah, it will show the impact of outlier. But what is the reason? Because confidence interval is depend on a standard deviation, right? And standard deviation is influenced by outlier. Standard deviation will going to increase because of outlier. Then that same changes will happen in a confidence interval, right? Is it clear now? What happened with the confidence interval with the outlier if we have outlier in a data? Okay. Now today's next question is, what happened when we introduce more variables to linear regression model? Or what is the impact if we add new variable in a linear regression model? I will write down the question. Till then you can think what will be the answer for this question. Okay. What happened when we introduce more variables to linear regression model? Okay. So we know In our linear regression, we have R square, right? And also there we have adjusted R square. The question will, it might be like, what is the impact if we add new variables in a model on R square and adjusted R square? It could be like this. Okay. So when we are performing any of the regression model, there we have R square and adjusted R square. If we add any of the new variable, the R square always increases. Okay, or at least remain constant because of ordinary least square of sum of the squared error. Because of OLS, the sum of square error never increases by adding more variable into the model. Okay, see what is the impact of the, if we are adding new variable into that, new variable into model, the impact on R square is like, it will increase or it will remain constant. By why it will increase and why it will remain constant? The reason for that is, in OLS, the sum of squared error never increases by adding more variable into the model. Okay, hence the R square does not decrease. Okay, because if our error will not, if our errors never increases, then our R square value will not going to decrease. That is the reason. Okay, then what is the impact of that on adjusted R square? Right, adjusted R square is nothing but a modified version of a R square. Okay, what is that? It is the modified version of R square. The adjusted R square is increased only if new variable improves the model. Okay, if the model will not going to increase accuracy after adding a new variable, then it will going to decrease, right? So if we are considering two parameters, if we are adding new variable, the impact is on major on two parameter, R square and adjusted R square. The impact on R square is like, it will not going to decrease anyway, it's just going to increase if you add new variable there. Okay, or at least on a same point. But with the adjusted R square, the condition is like, if the variable is adding some information into that, improve accuracy of our model, then it will going to increase. But if that variable does not adding any kind of information in our model, does not increase accuracy of our model, it is going to decrease. Okay. Yeah, and if anyone asks you the reason why R square is not decrease or why it will be constant, the reason is like, in case of OLS, the sum of squared error never increases, right? If you add new variable, the sum of squared error never increases. That's the reason R square value always increase, or at least at the same point, whatever point he have at the starting. Okay. Now the next question. What is the relationship between significance level and confidence level? Try to give answer for this question. What is difference between significance level and confidence level. Okay, try to give answer in a chat window for this if you know what is the significance level and what is the confidence level at least. Then we can find out the difference. Okay, significance level is, what is the formula for that? Firstly, we understand significance level is 1 minus confidence interval. That means significance level is our alpha, right? If significant, sorry, if significance level is 0.05, the corresponding confidence interval for that is 95% or 0.95, right? But the significance level or alpha, what is that? Okay, what it is giving us, what is the information it is giving us? Okay, the significance level or the alpha is the probability of making the wrong decision when null hypothesis is true, right? That's why we always conduct this as much as less as possible, right? Always the significance value was like from 0.05 to 0.01, like that. Okay, and the confidence interval, what is that? The confidence interval is the range of likely the value of population parameter. For example, population mean will be like, right? Confidence interval, confidence level is the range of the values in between our population parameters, such as mean of the population parameter will lie. Okay. For example, if you compute 95% confidence interval for the average price of an ice cream, then you can be 95% confident that the interval contains true average of all ice creams, right? True average cost of all ice creams. Okay, then the significance level and the confidence level are, sorry, yeah. The significance level and the confidence level are complementary proportion of a normal distribution, right? So in a simple term, significance level is nothing but the probability of making the wrong decision by rejecting null hypothesis. Okay, you might be go wrong and this much the percentage of that, right? That is the significance level. And the confidence level is, it is the range that we confident our future outcome, our future mean will lie in that, right? So if we have 95% of confidence level, so 5% will be our significance level. Getting it? Is it clear? Is it clear now what is the significance level and what is the confidence level? What is the difference between that? Okay, what it could be represent. Okay. Now, the next question is, what is imbalanced data set and how to handle them? What is imbalanced data set and how to handle them. Yeah, try to answer this question. What is the imbalance data set firstly? And if you know what is the imbalance data set, how to handle them? Okay. So firstly, we will understand what is the imbalance data set. Imbalance data set means that the population of one class is extremely large than the other. This is the definition of that. In simple term, if we have thousands of the data points, okay, in that thousands, 900, for example, we have classification problem like fraud and fraud detection model we have. In that, we have 900 of the data are considering fraud and 100 of data are considering a non-fraud. Okay, so this is the scenario of imbalanced data set. Okay, population of one class is extremely large than the other, right? Now, if we have imbalanced data set, how to handle them? Okay, there are two techniques to handle imbalanced data sets, either oversampling or the undersampling. Okay, what is the oversampling and what is the undersampling? Okay, we can consider it as upsampling and downsampling as well. See, the oversampling, that means when we have a variable in one of the data, in one proportion of data, we have 900 variables and 100 variables. Okay, so we just predict 800 more variables, more data points. We generate 800 more data points to balance the data, right? For example, we have 900 data points that is conducting a fraud and 100 of a data point that is conducting a non-fraud. So we will just generate that non-fraud, run that non-fraud 9 times to generate other 900 records. Okay, and balance our data, right? That means we have 900 fraud detection now and 900 non-fraud detection now. But how we are doing? We just continuously repeating the sample, that 100 samples 9 times to balance our data, right? Now, what is the undersampling then? Okay, this is the scenario for oversampling. What is the undersampling then? In a undersampling, what we done, if we have 900 of fraud and 100 of non-fraud, we just took 100 record for a fraud, right? That means 100 record for fraud and 100 record for a non-fraud, right? These are two techniques to handle imbalanced data set. But yeah, there we have some disadvantages for each technique. Okay, but if anyone asks you which is the way to handle, this is the way, and this is the this is the imbalanced data set. Like if you are going to do undersampling, you are going to lose data. Okay, if you are going to do oversampling, then you might be generate a bias model, right? Because you are repeating same of the data same time, number of times, right? Okay, but if the question is like what is the imbalance data set and how to handle them, this is the answer for that. Is it clear? Now, next question. In a logistic regression, if you want to know best features in your data set, then what would you do? I just write down the question, how to select best feature in logistic regression. Okay. Okay. So if you want to know which is the best feature, apply step function which calculate AIC for different permutation and combination of feature and provide you with the best feature. Okay. Apply step function. Okay. Which is calculating permutation and combination for each of the feature, and it will give you the best feature, the value of best feature, which is the best feature in this data set for a logistic regression. I'm asking about the logistic regression. Okay. Now, next question is, what is feature engineering? Try to answer this question. What is feature engineering? Okay. Give me response in a chat window. What is feature engineering? Okay. So the feature engineering is the process of using domain knowledge of the data to create features for a machine learning algorithm. Okay, feature engineering is just a process of using your domain knowledge, okay, to create new features for a machine learning algorithm that aren't into the training set. Okay, it can be produced new features for both supervised and unsupervised learning. Okay, the goal of this is like simplifying and speeding up data transformation while also enhancing the model accuracy. Okay, means when we are adding new features to our data, that is the feature engineering. As per the domain, we can add new data, new features in our data set to increase accuracy of our model. That is the feature engineering. It can be produced feature in both supervised and unsupervised. Okay. Yes, it is the part of ED as well. So the feature engineering is just a process of creating a new feature as per the domain of the problem, and it is not in the training set. Okay, it can produce new feature for both supervised and unsupervised learning. The goal of supervised learning is like improve the model accuracy and enhance the model performance, right? To speeding up our model and to speeding up our models transformation, right? This is the feature engineering. Okay, so thanks for today, team. Thanks for today, friends. We will meet tomorrow and same time. Okay, thank you. Till then, bye bye.